Hello and welcome to this week's video on the solutions to our assignments in the course Competition Policy and Strategy. This week's videos are going to cover assignment number 7 on the topic of horizontal merger. The name is not quite appropriate, as we will see later on in a later video within the series, because we will actually also cover the topic of vertical mergers as well this week. Alright. So, in the first exercise that we are going to talk about in this video more specifically, exercise 7.1, we are going to analyze a situation where M firms merge in a co-no competition. We will find out what is meant when people are talking about the merger paradox in doing so. Alright, so as we commonly do, we will analyze this situation, so a merger between M out of the N firms in a market, in a no competition market, using a model. All right, and this model is specified as is written down on the slides. So precisely, we know that we have a demand curve which reads price of quantity equals 6,600 minus 4Q. We know that in the initial situation, there are N firms in the market, and we know that each firm has a cost function, capital C of Q equals to 200 times Q. So what we immediately know by looking at this cost function is, of course, this is equivalent to saying, well, all firms have constant or identical constant marginal costs of 200, right? That's exactly the same. And in this situation, we will now first have a look at what happens if M equal 8 firms merge in this situation. So basically every firm but one. All right. After that, we will extend this model to allow for a sequential game, but let's talk about that when we're done with task A first. All right, so in task A, we are asked to show that the merger is only economically viable, and that, of course, should ring a bell. It means that profits only then increase, because that's what we mean by something being economically viable, if there is at least M firms that are actually merging in the situation where there is N equal 9 firms in the market in the initial situation. And then we are asked finally to interpret these results. All right, so I already hinted how we will approach this question, how we will try to sketch the answer, where we will have a look at the firm's profits before merger and after merger. And if the firm's profits increase with the merger, well, then we will say the merger was economically viable. Otherwise, it wasn't. Okay, so let's start by finding the profit of each individual firm in the situation before there is a merger happening. So that's what we're doing in this first row. We denote this pi I for the individual firm's profit with an additional index for pre-merger. So the individual firm's profit in the starting situation without any merger happening yet. Well, and this profit that is written on this slide, so 1/4 times, and then we have a fraction, and that reads 6,600 minus 200, all divided by n plus 1. This is all in brackets and squared. Then this profit comes from solving the comes by solving the profit maximization of these firms in a co-no competition. And we did this several times by now. So of course what we need to do is we state the profit function of the firm, then we find the profit maximizing strategies of the firm. So we maximize profits by the parameter of choice of each firm, in this case Q, because we are looking at the co-no competition, right? And by doing so we find the best response functions, we solve the equation system. We did this plenty of times before. And in the end, then we can find out that the profit of the firm, of each individual firm in the situation, reads this equation. All right? Now, because we know that we have n equal 9 firms, we can then simply plug in n equal 9 in this formula that we stated, that we found through the profit maximization strategy. And we then find out that the profit of each individual firm in this starting point, in this benchmark situation, so to speak, is 102,400. All right, so now we know what to compare the post-merger profits against, right? Because this is the starting point, the profits in the starting point. So logically, the next step will be to find out what are the profits of the individual firm after the merger, okay? And we don't actually need to do this whole profit maximization in Chrono competition process again. Because what we alternatively can do is we can understand that the new number of firms in the market, let's call it n prime, so the new number of firms in the market that results after the merger, that this number of firms equals the previous or the original number of firms in the market minus the number of firms that merge, so m plus 1. All right, so conceptually this means we have in the initial situation n firms in the market, then m firms leave the market because they merge and they come back as one single firm. All right, I guess I hope that's one convenient way to memorize this this equation, but at the same time you should be right once you understood where this comes from, it shouldn't be too hard to reconstruct it, right? All right, and we can use this. We can make use of this new number of firms in the market, and we can simply calculate the profits in post-merger by using this n prime in the profit function that we have already stated, right? Because everything else in the market stays the same, so we can use the same result in equilibrium that we used in the first step and simply change n for n prime for the new number of firms in the market post-merger. And if we do so, well, then we find out that, again, everything else stays the same, but now in the denominator of the fraction, we read n minus m plus 2, okay, for the new number of firms in the market. Now, into this equation, we can plug in any n, any original number of firms in the market, and any m, so any number of merging firms in the market. Which of course is quite handy, because we are asked to show that it's only viable from m equal 8 firms when there is n equal 9 firms in the market. All right, so we know n equals 9, and we won't change this, but now we are asked to show that profits of the firms only increase if m takes a value of 8 or more. Okay? How can we do this? Well, we can have a look at what happens if m takes any value that is lower than 8, so 7, and we can in addition consider a situation where m takes 8 and analyze profits in that world. Okay, and that's precisely what we are doing in these two and final steps on this slide. So we are having a look at the post-merger profits in case only 7 firms are actually merging. And we find out, and then in the second step, we consider a situation where m equal 8 firms are merging and calculate the post-merger profits. Okay. Now, towards the question whether or not the merger is economically viable. Let's start with the first comparison. Let's start with m equals 7 firms that are merging. If m equals 7 firms are merging, we can calculate the joint profits of the previously individual firms. Right? There were 7 firms in the market previously, and each of these 7 firms earned their individual equilibrium profits, which we calculated in the very first line, these 102,400. Okay? So all of these 7 firms combined had profits in the amount that is written here, 716,800. Okay, that is the combined profits of all 7 formerly individual firms in the market. This we now need to compare to the profit of the single firm that results from the merger. So post-merger, we have only one single firm out of these 7. And we know that post-merger, all firms that are active in the market earn the profits that follow the second equation on this slide. Yeah, this pi I post. So we simply plug in n equal 9, we plug in m equals 7, and find out that the post-merger profits, if 7 firms merge, are equal to 640,000. Okay, and now it's of course easy to see that the combined profits of all 7 firms that merge are actually larger than the firm's profits after merger. And by this we can show that that the merger for m equals 7 firms is not economically viable. These 7 firms combined are actually decreasing their combined profit if they merge. So it's not economically viable. Yeah. Now towards showing that it actually is economically viable if m equal 8 firms are now participating in the merger, well, we do of course exactly the same with one single but crucial difference, and that is now this time we consider m equal 8 firms that are merging. So we calculate the combined profits of 8 firms pre-merger and compare it with the profits of a firm in a market where 8 firms merged. So the profits post-merger. This exact same procedure that we just applied for m equals 7, so I don't think we need to go through the details once again, but this time when we make this comparison, you will notice that actually the post-merger firm earns a higher profit than all 8 formerly individual firms in the pre-merger world combined. And thus we have shown that actually a merger for any number that is lower than 8 is not economically viable. And we have shown that if there's actually 8 firms merging in the market, well then the merger becomes economically viable in this situation. Now, how is this related to the so-called merger paradox? Well, as you know from the slide, the merger paradox refers to a finding to the finding that at least in this symmetric Cournot situation, at least 80% of the firms that were active in the market need to merge in order for the merger to become economically viable. And what you will notice is that actually 7 out of 9 firms is less than 80% and 8 out of 9% is more than 80%. All right, so this is given an example for a situation where the merger paradox actually holds true. All right. Let's get rid of all of this and continue with task B. Now in task B, we are changing the game a little bit. First off, we are now assuming that there's n equal 4 firms in the market in the benchmark situation, and then we furthermore assume that 2 of these, so m equal 2 firms, merge. All right, and notably that's less than 80%, of course. However, we're not done yet. We will furthermore assume that the merged company will, with the merger, become a Stuckelberg leader. And what this means is that the game now takes a sequential form. So we now have two steps that follow one another. So the Stuckelberg leader, of course, is the firm that makes their strategic decision first, and the Stuckelberg follower is the firm or firms that make their strategic decision in the subsequent step, in the second step or second stage of the game. All right, so the 2 merging firms now become the Stuckelberg leader. They take their quantity decision first, and all the Stuckelberg followers, the remaining 2 firms in the market, become Stuckelberg followers, index F, and make their quantity decision simultaneously at the second stage. And what this last half sentence means is, on the second stage of the game, we have a Cournot competition, right? Because all firms, more than one, make their quantity decision, their strategic decision on the produced quantity at the same time. So a classic Cournot competition situation. So, all right. Stackelberg leader, one single merged firm, and then two Stackelberg followers. Right, this is just a little recap of what we've already mentioned, basically. So we are now analyzing a model that is called the Stackelberg competition, and this describes a sequential competition on quantity. Stackelberg leader chooses first, Stackelberg followers choose second. We solve this game as we always solve these sequential games throughout this whole lecture. Namely, we use backwards induction. And that means we start solving the game at the final stage. So in this time, in this game, at the second stage of the game, and then we consider this solution at the second stage of the game as given when we analyze the strategic decision in the previous, so in this case, in the first stage of the game. Okay, and backwards induction, of course, means that we keep moving one step back every time we found the solution on all ending nodes. Okay, so let's start right into it. As I promised, we are going to start at the second stage of the game. And at the second stage of the game, we already discussed that there is two follower firms. We call them with an index I, I, F for followers. And these two follower firms choose their quantity for any given quantity the leader already put onto the market. All right? And for any given quantity the other following firm puts on the market. So two follower firms, one called I, one called J. So this means that the profit function of the Stackelberg follower firm reads like it is written down here. All right. So what we have here is oh yeah, there's the second brackets. Let's mark them so I don't forget about them. So what we have in the brackets is price minus costs, all multiplied with the quantity of the individual firm, right? So this first part is the price. For price, of course, we can substitute the demand function that was given in this exercise, which read 6,600 minus 4 times Q, and Q, so capital Q, the total quantity in the market in this model can be decomposed into the individually produced quantities of the Stackelberg leader as well as both of the Stackelberg followers. That's why we have all these Qs that are summed up, or that summed up provide the total quantity in the market. This is, as I have hinted earlier, the marginal cost of all firms, because they're all symmetric in this model when it comes to costs. But yeah, so the constant marginal cost of 200, and then of course, yeah, Qi refers to the quantity that firm I produces. So this is the profit function of firm I or follower I. Of course, follower I and J are symmetric, so we simply would have to interchange indices I and J in order to state the profit function and profit maximization problem of firm J. In this example, we will do this only for firm I because again, you can simply switch indices and have the exact same result because both followers are symmetric. All right, so based on this profit maximization problem, we know the first order condition that is written on the slide. So we have the partial derivative of the profit of follower I with respect to the quantity that follower I produces. All right, so this is the first order condition of the profit maximum. And again, by symmetry, we know both first order conditions for the profit maximum, so one for each following firm. So what we can calculate for this is, or based on this, is of course the best response function of both followers. And what you will notice is that so far all we did is go through a very usual Cournot competition on this second stage of the game. There's only one crucial difference between the Kuno competitions that we have already analyzed in previous weeks and this version now, and that is that that the following firms, of course, do also consider the quantity of the Stackelberg leader in their profit maximization. Okay, but as you can notice, because it's just treated as given from the point of view of the Stackelberg followers, this Stackelberg leader quantity just ends up being part of the best response function of both Stackelberg followers, right? So nothing too crazy happening, just Kuno competition, the usual Kuno competition problem solving with one additional parameter. All right, so now we know the profit maximizing strategy, the best response of all firms that are on the follower stage, so on the second stage of the game. So what we know, of course, is for any strategy the leader plays, and for any QL, we now know the best response for both followers. So what we have done now is we have solved we have found the best responses of all possible nodes in the second stage of the game. Okay, so we can now consider this best response of all players in the second stage of the game when we move up one stage and consider the first stage of the game now. That's exactly what we're doing next. So after solving the second stage of the game, we are now taking this solution as given when we are analyzing the first stage of the game. And in this first stage of the game, the leader, the Stackelberg leader, considers the optimized decision on quantity on the followers, so they know this best response function, and considering these best responses for both Stackelberg followers, the leader then chooses their own quantity, accordingly reads profit maximizing. All right, so this results in the profit function that is stated on this slide. Let me erase this for better readability. So again, we have the same structure, of course, that we had for the followers. We have P of Q, the demand function that was given in this exercise, but this time we can, let me just move back one slide, because I think it's maybe clearer, or even clearer on the previous slide. So we have the same demand function, of course, but there's one crucial difference, and that is the Stackelberg leader can, for QIF and QJF, they can anticipate the best response already. Okay, so let's consider this slide again. The Stackelberg leader can now consider QIF as well as QJF as functions of the quantity the leader will choose, so as a function of QL, right? And that's already plugged into the profit function as it is stated on the slide. The constant marginal costs, of course, remain unchanged, and price minus costs all multiplied with the quantity of the Stackelberg leader then yields the profit of the Stackelberg leader. All right, and with that, you will immediately notice that we actually have a profit function for the Stackelberg leader that only depends on the quantity the Stackelberg leader puts out, only on QL. There is no QF in this function, simply because we already solved the second stage of the game and could consider the best response, so the best the profit maximizing QI and QJF as a function of QL. All right, so we can use this profit function and calculate the profit maximizing quantity the Stackelberg leader will put onto the market, right? So we simply maximize the profits of the Stackelberg leader by choosing the quantity of the Stackelberg leader. So we have the partial derivative of the profit function PL pi L divided with respect to the quantity QL, all right? And this all then can be solved, this first order condition then can be solved for QL, and thus we find out that the profit maximizing quantity of the leader in the first stage of the game is a quantity of 800. All right, and with this, if we know QL, we can of course plug QL into the best responses of both of our Stuckelberg followers. We already know they're both their best responses from the previous slide by when we were solving for the second stage of the game. And yeah, by doing so, we can find out that each of the Stuckelberg followers, follower I as well as follower J, will provide a quantity or produce a quantity that is 800 divided by 3. And with this, of course, we know the total quantity in the market, which is 4,000 divided by 3. With the total quantity and a given demand function, we can then calculate the equilibrium price and the equilibrium profits of all firms in the market. All right. So, we are now finally asked to interpret these results, and in doing so we are also asked to address the situation of the two firms not involved in the merger. Okay, so we want to particularly have a look at how does their situation change, of the not merging firms. So in the previous situation, we saw that all firms, so there were 4 firms in the market, just as a reminder, and they were all in co-no competition. In this previous situation, we can calculate profits for all firms. Of course, it's the same for all firms at this point, which equal to 409,600. Now, after this merger and then Stuckelberg leadership, Stuckelberg competition, we can then calculate that the total profits in the market, wait a second, right, not the total profits in the market, but this of course refers to the profits of the Stuckelberg leader, right? So we can see that after the merger and after this introducing the sequential game, the profits of the Stuckelberg leader actually increase, right? Let me just add for readability small comma here and here. So we actually see that the profits more than double for the Stuckelberg leader. So what we can conclude is that the merger is profitable independently of the number of firms that merge, right? And this is particularly interesting because this is now a deviation from the merger paradox. In task A, we saw that a merger in this co-no situation is only then profitable if at least 80% of the firms participate in the merger. And now we can show, simply by assuming that the merging firms actually become a Stuckelberg leader and this whole game now takes a sequential form, we can show that the merger is profitable even though only 50% of the firms merge and not the previously necessary 80%. And the reason behind this is, of course, the advantage through Stuckelberg leadership. So the ability of the merged firm to anticipate the best responses of the non-merging firms and maximize their profits accordingly.